Welcome back to our channel. Today we'll discuss about how to create an operating system. Creating a new operating system for a computer is a complex and challenging task that requires extensive knowledge of computer science, operating systems, and low-level programming. It involves designing and implementing various components, such as the kernel, device drivers, file systems, and user interfaces. Here is a high-level overview of the process. Define your goals. Determine the purpose and objectives of your operating system. Identify the target hardware platform and the features you want to support. Choose a development approach. Decide whether you want to build your operating system from scratch or leverage an existing open-source project as a starting point. Popular options for building an OS from scratch include using low-level languages like C or assembly. Design the system architecture. Define the overall structure of your operating system, including the kernel, device management, process management, memory management, file systems, and user interface. Consider factors such as performance, security, and compatibility. Develop the kernel. The kernel is the core component of an operating system that manages system resources and provides low-level services. Implement the kernel functionalities, including process scheduling, memory allocation, interrupt handling, and device management. Write device drivers. Device drivers are responsible for facilitating communication between the operating system and hardware devices. Create drivers for essential hardware components such as storage devices, network interfaces, and input/output devices. Implement file systems. Design and develop a file system to manage data storage and retrieval. Consider factors such as file organization, access control, and data integrity. Build system utilities. Develop essential system utilities such as command line interfaces, system monitors, and system configuration tools. Consider creating a graphical user interface, GUI, if you desire a user-friendly interface. Test and debug. Thoroughly test your operating system to ensure stability, compatibility, and security. Identify and fix bugs and performance issues. Consider creating automated tests and running the system on various hardware configurations. Documentation. Document your operating system's design, architecture, and implementation details. Provide user guides and developer documentation to assist future users and contributors. Continuous improvement. Operating systems require ongoing maintenance and updates to address bugs, security vulnerabilities, and feature enhancements. Foster a community around your operating system to encourage contributions and collaborations. Platform selection. Determine the target hardware platform for your operating system. Consider factors such as processor architecture, x86, ARM, etc., memory constraints, and device support. Different hardware platforms may require specific design considerations and specialized drivers. Boot process. Understand the boot process of a computer system. Learn about the initial bootloader, boot sectors, and how the operating system is loaded into memory. Consider whether you want to support legacy boot methods, e.g., BIOS, or newer ones, e.g., UEFI. Memory management. Study memory management techniques and decide how your operating system will handle memory allocation, virtual memory, paging, and memory protection mechanisms. Understand the different memory models, such as flat memory model or segmented memory model. Process management. Learn about process scheduling algorithms and how the operating system manages and switches between processes. Explore concepts like process states, context switching, inter-process communication, and synchronization mechanisms, e.g., semaphores, mutexes. File system design. Determine the file system structure and organization. Study existing file systems, e.g., FAT, NTFS, ext4, and their features. Decide how your operating system will handle file creation, deletion, access permissions, file metadata, and directory structures. Device management. Understand how your operating system will interact with hardware devices. Learn about device drivers, interrupts, I/O port communication, and DMA, direct memory access. Consider supporting a wide range of devices, including storage devices, network interfaces, graphics cards, and input devices. User interface. Decide on the type of user interface you want to provide. It could be a command line interface, CLI, a graphical user interface, GUI, or a combination of both. Learn about GUI frameworks, window management, input handling, and event-driven programming. Security. Consider security aspects in your operating system design. Learn about user authentication, access control mechanisms, encryption, secure booting, and secure inter-process communication. Implement security measures to protect the system and user data. Performance optimization. Focus on optimizing your operating system for better performance. Explore techniques such as caching, parallel processing, interrupt handling optimizations, and efficient memory management algorithms. Compatibility and standards. Ensure compatibility with existing standards and software. Study relevant industry standards, file formats, networking protocols, and application programming interfaces, APIs. Consider compatibility with existing software and libraries to facilitate application development. Inter-process communication. Understand how processes can communicate with each other within the operating system. Explore different mechanisms such as shared memory, message passing, pipes, and sockets. Determine how your operating system will support inter-process communication and synchronization. Power management. Investigate power management techniques to ensure efficient use of system resources and optimize battery life in mobile or low-power devices. Learn about power states, e.g., sleep, hibernate, power management policies, and how to handle power events. Networking. Consider network support in your operating system. Learn about networking protocols, TCP, IP, UDP, etc., socket programming, network stack design, and network device drivers. Decide how your operating system will handle network configuration, routing, and communication. Error handling and logging. Plan how your operating system will handle errors, exceptions, and system crashes. Determine how error messages will be generated, logged, and presented to users. Consider implementing error recovery mechanisms to ensure system stability. Debugging and profiling. Implement debugging and profiling capabilities in your operating system to aid developers in identifying and resolving issues. Provide tools for tracing system calls, monitoring resource usage, and analyzing performance bottlenecks. Internationalization and localization. Consider supporting multiple languages and locales in your operating system. Design mechanisms for internationalization and localization, including language packs, character encoding, date, time formats, and input methods. Kernel extensions and module support. Determine whether your operating system will support kernel extensions or loadable kernel modules. Explore how these can be dynamically loaded or unloaded to extend the functionality of the kernel without recompiling the entire operating system. System updates and patching. Plan how your operating system will handle system updates, security patches, and software upgrades. Consider mechanisms for distributing updates, verifying their integrity, and applying them to the system. Virtualization and containerization. Explore the possibilities of virtualization and containerization in your operating system. Investigate technologies such as virtual machines, e.g., hypervisors, container runtimes, e.g., Docker, and isolation mechanisms to provide flexibility and security in running applications. Documentation and support. Develop comprehensive documentation for your operating system. Include installation guides, system administration manuals, API references, and developer documentation. Provide user support channels, such as forums or online communities, to assist users and gather feedback. Remember that creating an operating system is a vast undertaking, and the above points provide a general overview of additional considerations. As you delve deeper into each aspect, you'll encounter more specific details and challenges that require careful thought and implementation. Good luck with your operating system development journey. Thanks for watching. If you like my video, please subscribe to my channel and like my video.